my talk today, I will talk about trying to find practical solutions in the landscape we have just heard about in the previous talks. I will focus on the sharing and publication of human brain data to a research infrastructure that has been released and that we are continuing to build and expand. So the Human Brain Project is a so-called European Union flagship project with a 10-year funding perspective. We are building EBRAINS, the European research infrastructure for brain sciences and brain-inspired technologies. This was launched October last year, and we are now expanding it to a full-scale infrastructure, also to continue after 2023. So there are many countries in Europe involved in HBP. There are 7 involved in establishing the EBRAINS. We have an AOSBL, international non-profit organization based in Brussels, to take over the responsibility for EBRAINS. And the research infrastructure is found at ebrains.eu, that is the web portal, and it is distributed at various locations in Europe. So, AI in HBP and EBRAINS. Well, taking a starting point in the EU high-level expert group on artificial intelligence, what I take out of it personally is maybe the 5 keywords at the bottom. You start with data, and preferably large amounts of data. There are analysis steps involved leading to interpretations, in turn giving us knowledge which result in action. And the AI are involved in several of these steps. My emphasis in this talk is on the left side here, on the data side, and actually on having data that one can say are less confusing or less mixed and more interpretable. So we find the key requirements the AI application should respect quite useful, and they are shown on the left side from the EU high-level expert group. What we're doing is shown on the right side. We have an HBP Society and Ethics activity in the project. They do a lot of very important things in this area. We have EBRAINS data governance with working groups and outcomes, EBRAINS technical coordination, and data curation, including ethics compliance steps. So the research infrastructure, of course, is about scientific data collections, archives. It's about computing systems and all the tools and software around that, and the equipment and the instruments. We have 6 main categories of services in our infrastructure. One is on data and knowledge, the so-called FAIR, findable, accessible, interoperable, reusable data models. Brain atlases, medical informatics, brain modeling and simulation, closed-loop AI and neurobotics, and interactive workflows on high-performance computing and neuromorphic computing systems. So this is actually, to some extent, going from left to right, from the data all the way to the action. And the data part is key in organizing and managing large amounts of data. The atlases are key because they give data a location in the brain, which is as important in neuroscience and brain research as the geographical information systems are in other disciplines. The modeling and simulation, for example, also includes services like the virtual brain. They're also part of this. And when you build virtual or physical robots which actually perform according to certain models of simulation, you are into the neurobotics. And to support the most advanced analysis and most compute-intensive ones, we have different computing systems, and even those systems that are actually brain-inspired. So I will talk about 2, primarily the data knowledge, FAIR data and models services. When it comes to human data, the personally identifiable data are not taken care of there, but in our medical informatics platform, which is about keeping the data, in this case, at hospitals. We have about 30 in Europe, not taking the data out, allowing researchers to perform analysis on data that they cannot really see themselves, but they get the results out. This is the federated approach, typically. So any personally identifiable data at the moment in our infrastructure is in this medical informatics domain. Then we have the pseudonymized data and the anonymous data. They are going into this data knowledge services, and I will try to explain what we mean by that. So we obviously need to have a framework, both to be compatible with GDPR and legislations, and also to send a clear message that we are running a serious service, which meets the expectations of the society. So we have various terms of use, access policies, privacy policies, and not at least in this context, the data use agreement. These are shared, of course, on our web portal. And the data knowledge fair data service is actually, in a way, a kind of a centralized system, because it allows researchers in Europe to submit data to not only one, but to a small cluster of HPC centers where the data is stored. There is long-term data storage. We make sure that the data are citable with DOIs, that there are licenses describing how you can use the package with metadata, and that there are metadata and descriptions that make the data findable and interpretable and reusable. Now, we must remember that in science in general, sharing is the new norm. And this is, of course, where we have to develop the solutions that makes it practical. It's important to give credits to the data provider, to greater exposure research, and also access to shared data assets to boost productivity, obviously. So in order to organize all the data, we have a knowledge graph, which takes care of all the different types of metadata and connect the pieces, so to say, in a very flexible way, which is quite different from classical relational databases. And this allows the system to grow and evolve over time. So this curation is a core part. Different clusters, if you like, or collections of data are going into curation, organized in the knowledge graph, connected to brain atlases and locations in the brain, and subject to various types of analysis, including with AI tools. So here are all the steps, starting with the request for curation on the left side, inside our project, but also from the outside, where one of the first steps is ethics, compliance, and permissions, meaning that before we can take any data in, we need to know what the situation is. This applies to all data, but to focus on human data, obviously related to also the fact that the institutions will have to approve that the data can go into this system. Then they're curated and go all the way to the right here, including the publication of the data. So the search engine have different types of access, but the simplest is the graphical user interface, where one can look up what we have in the system and, of course, do searches and filter and identify collections of data sets. At this point, there is about 1,000 researchers that have delivered various types of data, and some of these data sets are huge with thousands of files. And most of them are available. Some are embargoed until publication, and some are, as we'll see in the next slide, under review, meaning that we are preparing the solution for pseudonymized human data to be shared in a much stricter way. So in this system, the anonymized data, or sorry, not the anonymized, the anonymous data that cannot be traced back to individuals, they are shared if the permissions are in place to do this. The pseudonymized data will now be shared if they are strongly pseudonymized and the institutions agree to the sharing through the system. That will, what we are implementing now is a login layer where the researchers that have obtained a personal account in our system, they're identified personally. They have to agree to the conditions, which is our data use agreement, before they can have the access. Again, this is for strongly pseudonymized data, not for the lighter ones or those that are more easily identifiable. We're also building other solutions, but they are not yet available. So this allows us to also invite people to publish with data citations included in the publications. So for example, you have Nature scientific data, and you have data descriptors, which is the perfect format for these type of solutions, and in principle any journal. And it means that you can then not only cite other papers or your own papers, but you also cite specifically the data sets. This is the first example we had, which was before EBRAINS. So the name was Human Brain Project Informatics Platform. And you have a DOI, which actually points you directly to a so-called data card that gives you the metadata, that gives you an explanation of these data, a descriptor, and access to the data. And if these data would be human pseudonymized data, there would be a login, access control, and conditions have to be verified. So that was a little bit on this tour from data all the way to action. And our system is available at ebrains.eu, which is the entry point to a growing collections of tools and services, also from outside our own project. This is very much an externally oriented action. I'm looking very much forward to discussing the interesting aspects around what had been presented in the previous talks together with this, hopefully. Thank you very much.
Thank you, Professor Bjaalie, for your presentation and about EBRAINS and the Human Brain Project. I guess we will be hearing about this in the discussion later on.